Yeah, we are ready to getting started. The second day of our conference, Tuesday morning, as a normal tradition. The Tuesday morning is devoted to the ITA Open Session. That means it's a subject that ITA feels is important, and it's the only session going on at the time, so that we can have everybody assembled, and the intention is to come up with subjects which are relevant and which can be used for having input from the audience and a good discussion. So it's not just intended to be presentations, it's actually intended to be an open dialogue with inputs from everybody. Today, the subject is industry advances. It's in two parts. The first part, we will hear the 5 documents that has been produced as ITA report will be presented. There are 3 from working groups, working group 2 on research, working group 11 on immersed and floating tunnels, and then a combined product from working group 14 and 19 on mechanized and conventional tunneling. So they will do it first, and then the second part is a discussion on current and future topics for the working group. So there we will hear more details of how the working group actually works, what topics are interesting, and what should they work with in the future. And it's for that part I will ask you to consider to come with input for what you would think is important to ITA and to the industry for the future work of our working groups. As I already have said, working groups and the committees has been, at least the working group has been around from ever since ITA was established in 1974, and they have over the years produced many very useful documents which are recognized as valuable documents by the industry and by our member nation and used as requirement on many projects and contracts. And similar has the committees done since they were started 11 years ago. And I still find that the backbone of what ITA produces, the work we do in ITA, is what we produce in our working groups and committees. So, and that's the reason we have thought that this year's open session should concentrate on the work of the working groups and committees. So I can only welcome you to this session, and then I will hand over to our Vice President, Tarcisio Celestun, for leading this.
Randy. Yeah.
You? Oh, sorry. Randy. Sorry.
Good morning. I'm Randy Essex, and I'll make some introductory comments, and then I'll turn it over to Tarcisio. So 2 parts. The first is presentations of work that have been completed by both working groups and ITAtech activity committees. And Tarcisio will chair that effort, and we'll have a number of people giving presentations of their completed works. Then there will be 3 separate presentations that are more interactive. We have panelists who will sit here and offer commentary, and there are microphones in the aisles. So if anyone wants to have a comment or provide some feedback, please make your way to the microphones in the aisles here, and that way we all can hear what you have to offer. There'll be 3 working groups in the second session. Working Group 2, Research, Working Group 3, Contractual Practices, and Working Group 20, Urban Problems and Underground Solutions. And later on, I'll introduce each of the animateurs of Section 2, and they'll have a panel of presenters that they will then introduce. But at this point, I'd like to turn it over to Tarcisio, my co-chair for Session 1. Tarcisio?
Thank you. Thank you, Randy. We are now starting this open session, and I have the pleasure to mention that as just to say a few more words with respect to what Soren has already said. Actually, the working groups and activity groups are the core of the association, in the sense that they produce technical work. We are not a standardizing institution, but a lot of works which have been produced by working groups in the past and activity groups recently have become kind of standard for the industry. So for those of you who are not familiar, who are not still familiar with working groups and activity groups, I do encourage you to take a look at what has been produced. The meetings usually take place on Sunday and Monday, so they are gone for this time, but you can catch up next Congress, or you can also look at the web page, ITA web page. All these reports are available for free at the web page, so it's a very important source of information, and we are having here firsthand what has been produced in the past year by some of these working groups and activity groups. So the first presentation is by Heinz Erbar about the report produced by working groups 14 and 19. 14 is the working group on mechanized tunnel. 19 is the working group on conventional tunnel. So Heinz.
Thank you, Tarcisio. Dear ladies and gentlemen, it's an honor for me to present you the ITA report number 17, which is, as already mentioned, a common project of the working groups 14 on mechanized tunneling and 19 on conventional tunneling. It's printed 2 days ago, I think, and some copies are available here. The title of the newest ITA report is Recommendations on the Development Process for Mined Tunnels. At the occasion of the World Tunnel Congress 2010 in Vancouver, we were thinking about new projects and also ITA Working Group 19, and the question was which tunneling method should be applied in a project? Mechanized or conventional, or what are the most important criteria? Very soon we saw that we can't relate this question only to one single project or to an entire project. As you know from your experience also, many projects use both methods within the same project, as you can see on this slide here from the project in New York, 2nd Avenue subway project in New York. In blue color you see the TBM drives, then in orange color caverns, in green color the conventional drive and cotton cover drive. So in many complicated projects we utilize all the different excavation methods. Then after 2010 we started with our project. ITA Working Group 14 proposed a short table with the pros and cons of the different excavation methods or tunneling methods, and we saw quickly that it is not possible to answer this question on a few pages, and we agreed that we would like to start with a common project, and we did it at the occasion of the World Tunnel Congress in Geneva, and the first draft was discussed in Iguazu. Then later on we had already a nearly final draft at the last World Tunnel Congress in Dubrovnik, and finally we have it now printed and ready. Our general report starts with the general analysis of the different project requirements. The list of the requirements is by far longer than only the so-called magic triangle of the project management, quality, costs and time. It's pretty obvious that the ground conditions, but also geometrical restrictions, logistics, mainly in the form of the accessibility of the site, but also occupational health and safety, environmental aspects, for instance, ground vibrations due to the drill and blast method, can have a major impact on the selection of the tunneling method. But also the local market conditions or the public opinion. I remind you the discussion about the Fehmarnbelt tunnel, where in Germany still is a discussion whether it should be a submerged tunnel, a bored tunnel, a TBM tunnel, and not a submerged tunnel. So also the public opinion can influence the selection of the tunneling method. And finally, I think it's the right of each owner and also of the contractor to make his own risk analysis, and based on the results of his analysis, he will take the choice on the tunneling method. The definition of measures to fulfill these project requirements depends strongly on the individual project phase. In some cases, the selection of the tunneling method can already be done in the earliest project definition phase, but in many cases it can be done only during the further design phase. And if the owner has no compelling reasons for the selection of the tunneling method in the design phase, he should tender both methods or tender one method and allow contractors alternatives for the second tunneling method. In our report, we have certain tables where you can find the details on this. The relevant tasks in the selection process are shown in the table 3. This is maybe a little bit small to read, but you have a better table in the printed version, or at least you can read it a little bit better. And it should be the guideline for the activities of the owner and his representatives. So what should be done on the requirements of geology, of logistics, and all the project requirements depending on the different project phases. And based on this table, also the content of the report is created in the following way. We have a short glossary, and the most important chapters are chapter 4 to 8. In chapter 4, we have a rather long description on all the project requirements, and later on we go into the details of these project requirements in the chapters 5 to 8. So the chapters 5 to 8, you can understand them only if you read before also chapter 4. This is the basic information on the selection of the tunneling method or on the requirements. To whom shall this report be addressed? It's quite clear to all the project partners, the owners, the design engineers. Our report was mainly written with the design build model, and then the engineering geologist and the contractor. What are the goals of these recommendations? The goals is to promote the international understanding of the development of underground projects by unifying the terminology, by presenting an overview and recommended structured approach for the project development. The field of use, we were a very international group with 9 different countries, and we had comments from the United States, from Brazil, from all over the world. So we think that this content shall be valid for most parts of the world, even if it is based mainly on the design-build contract model, but we give also some indications what has to be done in the case of a design-build contract. Therefore, the recommendations highlight only the most important principles, and they don't deal with too many details, which you can find very often in national codes. We had to undergo a, I think, quite strong and strict process with the EXCO's peer review, but this was a very good experience, and we got some recommendations. And EXCO recommended that a section with direct comparison of the performances of the two tunneling methods in the different geotechnical conditions seems to be missing, that we should add it. And if you have a look on the list, the considerations should be given to typical advance and penetration rates depending on various parameters such as ground mass characteristics, flexibility of many excavation phases, and so on. And finally it says, it's highly recommended that a new document dealing with that issue should be included in the list of the future tasks of the working groups. We were discussing this on Sunday, but this is quite a very huge task, but there is a database available from ITA. Maybe we can do it. And there is in the report is included a small list of such projects, typical and exceptional projects from both methods, and this may be the basis for the future work. I will come to the end. These were the participants in this work from both working groups, and I thank all of them for the big contributions to this report. And to you, thank you very much for your attention.
Thank you. Thank you, Heinz. The second presentation is by Timo Leitnen from the Excavation Activity Group, ITAtech Activity Group. And he will talk about vibration control in urban drill and blast tunnels. The subactivity group is quality drill and blast tunneling.
Thank you, Tarcisio. Ladies and gentlemen, good morning to all. And thank you for your interest on this topic that I'm proud to present this document prepared by ITAtech. And like mentioned by Tarcisio, it's the activity group excavation, and within the excavation, which is a large topic itself, we have a sub-activity group called quality drill and blast. And actually the topic of this paper is vibration control in urban drill and blast tunneling. So, the background of this document is that obviously the quality of the tunnel produced by drill and blast method can vary a lot, and typically after the excavation phase, the biggest influence is with the geological conditions of the rock and material where the tunnel is made. But with a good drill and blast design and proper and modern technology for drilling and blasting, the quality and the quality control, the end result can be greatly improved. Then the second point, that the drill and blast practices and the standards covering the drill and blast practices in different countries, they vary quite a lot. So therefore it's not always so easy and simple to transfer the best practices from a country to another one. Of course, the geological conditions have a big influence here as well. But then, based on these two facts, we thought that we will it would be helpful for the industry if we tried to put together a summary of the different standards covering this drill and blast tunneling, and then share the recommendations on how could the quality and the result be improved. And also, since there's a lot of technology being developed by explosives suppliers, equipment manufacturers, and software companies to help with this, the idea was also to put together information about this. And so the objectives of the document are sharing the knowledge of the demanding drill and blast tunneling projects in urban and sensitive areas, then look at the regional standards, regulations and typical verification methods for tunneling and tunnel quality, and then share the knowledge of best practices for reducing vibrations, increasing tunneling quality, safety, and to help performing tunneling and underground construction projects with drilling and blasting method more efficiently. So those were the objectives of the document. Within the working group in the ITAtech, which is a group consisting of the prime sponsor representatives, the companies that showed most interest in this topic were Sandvik, Amberg Technologies, and Atlas Copco, and these companies contributed to this paper from the ITAtech group. Then for this literature study part of the document, where we were looking at the regional standards within Europe, we were thinking about trying to reach that globally, also get an understanding of the regulations in globally, but we thought that this is too big of a task at this point of time, so we just looked at the different standards in Europe, and then the students from Leoben University and then also from the Lappeenranta University of Applied Sciences, two students were working intensively on their thesis work to help with this. And then Juha Kukkonen from Sandvik was facilitating this part of the work. And then we had a number of other companies who were contributing to this work. And then we had the peer reviewers from the ITA family, all experts in this field. So there's just very shortly the content of the paper. First part is the blasting generated vibrations, and a short description of blasting induced vibrations, effects of the vibrations, and methods of measuring these. And then the second part, which page-wise, this is about 20-page document. About half of the pages are about giving a summary of these different vibration norms and regulations in Europe. And then the last part, which I believe is the most important and the most interesting part, is then how to control the vibrations. And there's a very brief overview of available methods for controlling blasting-induced vibrations. In this document, we did not yet include any comprehensive description of available technologies for this, and that's what we are thinking to continue with. So the paper is here. I have a box of these. I'll place the box next to the door, so the ones who are interested can pick up a copy of this after this, and then what we are thinking of is to continue to the phase 2, where then the technologies, different technologies to help with this and control these vibrations are presented comprehensively. And with this, I invite all the interested parties to let me know if you want to participate in this. And of course, in ITAtech, the contributors and the people who can actively work with these projects should be either prime sponsors or supporters of ITA. That's what I have to say. Thank you very much.
Thank you. Thank you, Timo. Next presentation is by Elena Kiriotti. She is Vice Animator of Working Group 2 on Research. The animator is Chung-Sik Yu, who is also here. And the presentation is 20 years of fiber-reinforced concrete tunnel segments, practice, lessons learned, and proposed design principles.
Thank you, Mr. Chairman, and good morning, everybody. I'm more than honored today to be here to present the result of a few years of intense work within the working group number 2 on fiber-reinforced concrete. I have to thank, in particular, the devoted team of our working group that has worked very hardly on this topic. Giuseppe, that is in the first row, and Giovanni from the University of Brescia, that have initialized this work that has been shared among our working group, among people that are familiar, not only familiar with this topic, but that belong to the international standardization team that work on ACI, that work on FIB, that work on Eurocodes. So the idea that we have in our working group was to develop a document that can fill for some aspects some missing information according to our experience of practitioners and designers in the documents that are already existing. In particular, we want to take advantage of more than 20 years now of fiber-reinforced concrete practice and try to see if we could get a feedback from the real cases and the difficulties that we have in designing such structural element in the day-by-day engineering life. We wanted to support a performance-based design of fiber-reinforced concrete. That means all kinds of fibers respecting short and long-term requirements can be used, and we are to be focused on performance of this material and this composite material. We want to include some research advances and provide some additional design principles specific for segmental lining as far as loading condition and design procedures are concerned. So why fiber-reinforced concrete? Well, we probably all know that fiber-reinforced concrete enhance the resistance to crack development through the post-cracking strength. Then it considerably increase the toughness of the composite material, and it can allow optimizing the reinforcement for diffuse stress and can be combined with traditional reinforcement bars where high localized stress occur. And this with the addition of very limited quantities of fibers. The key factors for such a success, growing use of fiber-reinforced concrete in segmental lining, precast lining for tunnels is mainly the enhancement of the general structural behavior. So it allows a stable development of the splitting cracks, a reduction of the stirrups They are placed in the most solicited areas, and a possible or complete replacement of the shear reinforcement. And it also allow an improvement of the industrialization process. So the time is optimized in shaping, handling, and placing the rebar. So we have an optimization of time in production, and also less space required for storage and less waste. And this is really clearly the result of the feedback that we got from the case histories that we have collected. We have collected a total of 73 case histories in the use of fiber reinforced as fiber only or hybrid configuration, so fibers plus traditional rebars. And for 16 of these case histories, we are very well documented the project. You can find the project sheets at the end of our publication. For each project sheet, we have the project description, the tunnel characteristics, the mix design of the concrete, the environmental and geological conditions, the excavation method is defined, then the TBM data, and the reinforcement of the segmental lining. So the result that we can see from these 73 cases that have been collected is that in the majority of these cases, fiber only were used, that the applications that have been done are spread in all kind of diameters, even with big diameter, more than 10 meters, and actually selecting and choosing in between a fiber-only solution or a hybrid solution is a matter of the load conditions, of the geotechnical conditions, and the specific project case. What we have observed also is that the use of fiber-reinforced concrete has dramatically increased in the last decades. And so the question that we asked ourselves was, are the existing recommendations sufficient? So we went through the existing recommendation, and we according to our analysis, there are 3 groups of existing recommendations. Those who are focused on the material behavior, on the material behavior that can be characterized on small samples, those that are related to the behavior of the general structural elements like slab and beam, and there are few recommendations and standards that deal with the case of tunnel lining, specific application for tunnel lining. But 3 out of them are specifically for steel reinforced fiber concrete, and the ACI is the most comprehensive. Still, we thought that we could add something according to recent development of research. And to give you an example of what kind of information we want to share among the industry and among the engineering community in tunneling, is that there is a need for some additional specification for these particular structural elements that are the segments, because they undergo specific forces, especially during, for example, the thrusting phase of the TBM. So in this case, we have what we suggest is that we have a deep look at the local behavior and the global behavior. The local behavior of the single element, of the single segment, to analyze the tensile transverse stresses, but also a global behavior of the different segments in the lining. And this especially when the fiber only are used, because according to the research, we feel that the irregularities of contact in between segments can have an important impact on how the stress is distributed and how the fiber-reinforced concrete behave. And so we suggest that nonlinear numerical analysis are used, and experimental tests are also used. And that specific sensitive analysis are done for the case of the irregularities. For example, the procedure that we suggest that is that we start with the numerical analysis, nonlinear numerical analysis on simple models, simple 2D models that can give us in the elastic field, that can give us the initial ratio of reinforcement that is needed. Then we pass to a more complicated numerical model, 2D always, but in which we can simulate the loading condition and the variation of this loading condition. We can simulate the irregularities, we can simulate the imperfection that we, can go on during the construction, and then we go through the 3D numerical model as the last step. And we really recommend that the 3 steps are followed, that we don't start immediately for the 3D numerical modeling. And then, of course, experimental tests on small samples or full scales on tunnel elements for studying the local and the global behavior are a useful tool for proving our design approach and not for substituting it. So, working group number 2, thanks you for your attention.
Thank you, Elena. Next presentation is by Christoph Eberle from the subactivity group on precast fiber-reinforced concrete segments. So it's very nice that we have 2 reports released at this time on this issue, which address different aspects of the same subject. Christoph?
Oh, yeah. Thank you very much, Mr. Chairman, ladies and gentlemen, good morning. My name is Christoph Eberle. I'm pleased and proud to represent the ITAtech sub-activity group dealing with precast reinforced concrete segments here today. Here you see a list of our current authors. On behalf of my colleagues, I would like to give you an overview of who we are, what we have been doing the last year, and what we plan to do in the future. Thank you. Let's try that. All right. Hope you can hear me better now. I'll also talk about the content of our current guidance document, which you can download from the ITA website. Well, pretty much now. It should be online now. Well, who are we? As you've seen on the previous page, we are a pretty mixed group of individuals. We believe we represent a cross-section through the part of the tunneling industry, which is dealing with fiber-reinforced concrete. The general idea when we established this group in 2012 was to draw on expertise from designers, manufacturers, and contractors to identify what the best practice and the use of fiber-reinforced concrete actually is, and to make this knowledge accessible to the general public. You might also have noticed, going back here, that we are somewhat Eurocentric. The reason for that is quite a few practitioners with hands-on experience are operating in the European market, and we have a large number of reference projects in Europe. And, well, basically, in particular in the UK, fiber-reinforced concrete segments that's the default. It's very difficult to sell bar-reinforced concrete segments to a UK contractor. So what exactly are we doing in our sub-activity group? Well, here, we produce the skyline, the guidance document. In a nutshell, this is about making our experiences on what works and what doesn't work, and as well as on what's important and what's not so important in fiber-reinforced concrete segment design, accessible to tunneling practitioners. what we want to do is we want to seek to empower segment designers to use fiber-reinforced concrete when the conditions are right. But we also want to provide advice on when the conditions are right in the first place. The guidance document which we produced, it's not a textbook, it's not a standard, and it doesn't contain a walkthrough for segment design. It contains relevant background information, which is intended to assist the practitioner to come to his own conclusions on whether fiber-reinforced concrete is the right material for his or her job. Next slide. On the screen, you see what we've done since Dubrovnik, where we have published our volume 1 of our guidance document. And I see there's a mistake on the slide. It should read peer review of guidance document volume 1 design. Apologies for that. This also brings me to the activity which took up most of our time in the last year, which was a peer review, which we undertook together with Working Group 2. And it was a Working Group 2 did a very good job, and they identified a huge number of issues which we together put right and identified. And well, we had a lot of interesting conversations, and I have to say I certainly learned a lot. Going forward, what we're doing right now, we are producing volume 2 of our guidance document. Volume 2 deals with basically how to get the grey stuff specified, how to get it into the mold, get it out of the mold, how to install it, and to do all of that to a good quality. And our current aspiration is to publish volume 2 in time for Bergen 2017. Just a word, as we now have our first final document, we are very interested to get feedback from the practitioners. And we plan to really listen carefully to what you all have to say on this document. It's perhaps what its good points are, what its shortcomings are. And we plan to review and update this document on a regular basis. Also, we would really be very interested to learn if there is a need for additional guidance documents coming from the ITAtech sub-activity group dealing with precast, fiber-reinforced concrete segments. If you want to get in touch, please do so via the ITA website or email us directly. Right. So what's in volume 1 of our documentation? We already heard a very good presentation from Elena about the more technical aspects of fiber-reinforced concrete design. So I do not plan to repeat on this subject. Just a quick walkthrough. What are we talking about? Section 1, we talk about design standards, we talk about fiber types, fiber properties, and in particular, we talk about the behavior of the composite material which fiber-reinforced concrete actually is. Section 2, the design. Most people will be most interested in that. Obviously, we talk about ULS design, we talk about SLS design. We have a section on numerical modeling, and we have a section on how to design for fire load cases. Section 3, the performance specification of fiber-reinforced concrete. From my personal point of view, this is one of the most important aspects of this document. This is the handover point between the designer and the user. It's very important to pay good attention here. We talk about testing in particular, about applicable tensile strength tests, flexural strength tests, and about the fiber specification of the fibers. Section 4, sustainability. As you know, fibers, you tend to have a lower fiber content than you would have a reinforcement content. So there are a lot of carbon savings which you can actually make by using fiber-reinforced concrete. Now, obviously, using fibers has a very limited impact on the amount of cement which you put into your segments, so the overall potential for carbon footprint reduction is unfortunately somewhat limited. Also want to make some general comments on the content and the emphasis which this document takes. And here on the picture, you see the diversity of fibers which are actually on the market. This diversity is also well represented in our group, and we are also aware of that we are Eurocentric, and we see this as an aspect which we have to manage as a group. So the route we took as a sub-activity group, we decided to set up our document similar to a performance-based specification. So we describe what the fiber reinforced concrete is supposed to deliver, in which situation, and how this can be designed, specified, and tested. But we leave it to the manufacturers to actually provide the product which complies with these performance requirements. So, in consequence, what we hope to have achieved and what we believe to have achieved, that the content of this guidance document is relevant for your segment design, regardless which particular fiber or fiber material you're planning to use. Basically, that was it already from my side. I would like to take this opportunity to thanking the EXCO for facilitating production of this document and for guiding us along the way. And also a big thank you to Working Group 2 for the peer review. We put a lot of work into that and a lot of effort. And, well, that's it from me. Thank you very much for your attention.
Thank you very much, Christoph. Our last presentation is going to be by Jonathan Baber from Working Group 11 on Immersed and Floating Tunnel. And he will present the owner's guide to immersed tunnels.
Okay, thank you, Tarcisio. Very pleased to be here this morning to talk to you about our latest publication, An Owner's Guide to Immersed Tunnels, which is version 3 of the document. I haven't put up a list of credits for the authors involved, but I should thank them all because we've had input from 15 experts around the world and a separate group of 6 or 7 reviewers helping us produce the document, as well as the peer reviewer from ITA. They're credited within the document, so you can see their names there. The purpose of the guide is really aimed at promoters and owners to give them some insight into the immersed tunnel technique and to answer some of the questions they may have if they've never come across this particular type of construction before. In a nutshell, we thought if we can answer the question, what does an owner need to know and document for the planning, construction and operation of an immersed tunnel, then we'll put them in a pretty good place to make informed decisions and to start with the implementation of the project. So the structure of the guide is quite a simple structure to the document. We have a fairly short front-end document, which is in 4 parts. First of all, we set out our objectives, much along the lines I've just described. Section 2 gives an introduction to immersed tunnels. That really sets out the different components of an immersed tunnel project and the different construction techniques that are involved. So at a high level, it gives a first good level of information to someone who's new to the subject. Part 3 gives an introduction to IDV. That's instrumentation, documentation and verification. This is a systematic approach to capturing information about the tunnel structure or the tunnel crossing, which can be of assistance for later operation and maintenance of the tunnel. Then we have Part 4, which is a series of appendices or annexes. These deal with a number of subject areas in a standardised format, and this is the meat of the document really, is where the detail is contained. And the table on the right-hand side there is the set of subheadings which feature in each one of those appendices. We go through what the subject area is, give some basic description. We have a section on when things need to be done, so when decisions need to be made, whether it's during design phase, construction or through operation. We give some information on specifications, what you might expect to see in specifications. We have a section on documentation, so an owner can understand what sort of documentation should be produced through design, through construction and through operation. We give a few expected values in relation to those specifications and behaviour of the immersed tunnel structure, and a section on analysis talking about requirements for design, but that might also include operational stage monitoring. We set out a few behavioural tolerances, limits, deviations that are typical for the projects that have been constructed around the world, and we give some advice on remedial measures and actions should those limits, deviations not be met. Then finally, we have a few links to other processes, so cross-referencing within the document so that an owner doesn't miss anything, and we have a small section on responsibilities in terms of what you would expect an owner to be responsible for, what you would expect a designer to look after, and what would fall to the contractor. And we try and deal with the different contract forms within that section as well. So in terms of our preparation, we first published the document in 2011, which was the front-end document and the first 6 annexes. Last year, we published second edition with a further 9 annexes, and this year, our third edition, we've added 13 additional appendices to the document. We're planning 45 in total, so it'll be quite a large document when it's finished, and we've now completed 27 of them. So it's becoming quite a comprehensive and certainly a very useful document to reference. I'm going to take you through a few of the annexes we published this year. I won't get into too many details, but just to give you a little bit of an overview as to what this year's publication contains. We have an annex on tunnel element transportation. For those of you not so familiar with the immersed tunnel method of construction, the tunnel is constructed using precast or prefabricated tunnel elements, and these can be built at a distance remote from the tunnel crossing site. So there's a need to transport them to the tunnel crossing site where they can be immersed down into a trench which is dredged in the riverbed or seabed. So that first annex deals with the different methods of transportation and the areas that need to be thought about for that process. Connected to that, we have an annex on tunnel element mounted equipment. This describes all of the equipment that needs to be attached to the outside of a tunnel element to allow you to transport it and to immerse it down into your dredged trench. So this deals with control systems, measurement systems, survey systems, and guidance systems. We have an annex on exceptional load cases. Because of the nature of an immersed tube tunnel, there's some loadings which need to be considered which probably don't for any other form of tunnel. To give an example there, immersed tunnels are very shallow under the very shallow depth beneath the riverbed or seabed, so we have to think about the influence of sunken ship loading on the roof of the tunnel or ship grounding, and protecting the structure from falling and dragging anchors. So we try and deal with some of the very specific loadings which we have to think about there. We have an annex on approach structures. The immersed tunnels always need to connect to a terminal structure on land, and so that deals with the sort of type of structure and how operational buildings are configured. We have an annex on water stops. For the concrete tunnels, quite often they're built in a segmental form and have a number of joints through the structure, so that gives some guidance on the type of water stops that are common and what's considered to be effective. There's an annex on tunnel element construction using the factory method. This is a method developed for the Orison tunnel in the 1990s and has since been used elsewhere. And it's a very rapid production process for the tunnel element structures. And it's planned to be used on future projects such as the Fehmarn Belt project between Denmark and Germany. We have an annex on water conditions. So during the process of transportation and immersion of tunnel elements, this covers all the things that need to be considered in terms of tides, waves, water salinity, all of the inputs to the planning that's required for those processes. And we have an annex on waterproofing membranes. There are a number of different ways in making tunnel elements watertight. And for some forms of structure, there's an external membrane applied, and that could be steel, or it could be a spray applied or a sheet type product. So we deal with those products and materials and how they should be implemented. And last two, We've been annexed on dredging. That's a big part of an immersed tunnel project, as dredging required to form the trench in which to place the elements. So this deals with the different types of dredging equipment, the level of accuracy that could be expected, and environmental protection. And lastly there, we have an annex on temporary pre-stressing. For concrete tunnels which are built in a series of segments, they need to be clamped together to form a rigid body so that the tunnel elements can be floated, transported, and immersed again. And temporary pre-stressing is the way to do that. So this gives some guidance on how that can be implemented. So moving on from here, our plan for next year is to complete the final 18 annexes. There's still quite a lot of information to put together. We're well on the way for that. We've had contributions from 15 experts around the world. By the time we finish, it will be well over 20. So I need to thank everybody in the working group for their hard work over the few years and getting to the point we're at. And just before I finish, I'll say in parallel, we've also produced an advice leaflet on environmental protection, which is a very important subject to us for immersed tunnels, so that clients and owners understand how environmental impact can be successfully managed for immersed tunnel projects. So that's it. Thank you very much.
Thank you, Jonathan. This brings us to the end of this first part of the session. Second part will start immediately after. So I would encourage the audience to go through these reports, which are available at the ITA website. Some of them have important compilation of information, and others have guides which for sure will shape the way how designs will go on from now on. Thank you. So now I invite both Priscilla Nelson and Randy Essex to share the second part of the session.